So tonight we are going to be talking about HTTP. Fair bit of warning. I stumble over that acronym a lot, so you're going to hear me slur that thing. So HTTP and Ajax, and we're going to be talking about promises as well. So let's just get kicked off. Let's start it. There's my Zoom screen. A lot of windows open. Who can tell me what a promise is? Just in a very, very broad terms. What a promise is. Async, yep. A promise is an object, sure, yep. I don't know if they exist everywhere in JavaScript. The promise is a very specific thing. A contract to deliver data at some future point. I think that's the most accurate statement so far. IOU, fantastic. The way to avoid callback hell, 100%. Anyone else got anything? Code that hasn't run yet until another action is resolved or rejected. I like that as well. Everywhere in async JavaScript. Placeholder in sync code for an async value. I like that as well. So a promise is this idea that's really surrounding asynchronous JavaScript, right? We have code that is going to run, and we don't know when it's going to finish doing what it needs to do. Okay, who can think of something that might take more than a second to do? API call. Yep. APIs are the given, right? Downloading all of Google. Yeah, it'll take more than a second. Round trip to a server. Yep. Run through a large array of objects. So if we're talking about like a for each or a for loop, we'd consider that a synchronous call. Database call, anything, yeah. So it's essentially anything, and there's a lot more to it in the background, and I don't want to get too focused on async JavaScript just yet. But what happens is there are certain things in JavaScript that are synchronous. Everything that we have been dealing with, we've been dealing with maybe one thing that's asynchronous so far, but almost everything we've been dealing with in JavaScript is synchronous, right? JavaScript and well, okay, let me ask you this question. What is the difference between synchronous and asynchronous code in JavaScript? Same time, not the same time? Sure. In order versus not in order. Okay, independent events. So really what the big difference between synchronous code and asynchronous code is that synchronous code is what we would call blocking. All right. So JavaScript is going to run that code until it is finished. All right. And then once it's finished, it's going to continue on with the rest of the code. Whereas asynchronous code is considered non-blocking. Okay. So we can say we load up our React page, right? And we have this thing that's going to take a while, which we'll talk about tonight with an API call. We want that page to continue loading. We want that page to do its thing. We want the user to be able to use that page, and when this function call that's going to take a long time, or maybe it might be 1 second, it might be 1 minute. We don't know, right? When it's finished, we want to load that stuff in there. But we don't want to block any user interaction. We don't want to block any rendering of any of our components to the page. We want to make sure that our page is usable, okay? So asynchronous code kind of takes that, runs it in the background, and like I said, there's some definite like higher level stuff that I'm not going to go into quite tonight, but you will go into, especially once you get to Node. And it runs it we asynchronously, right? So it's non-blocking. So that's a really major thing to remember, especially when it comes to like job interviews and things like that, is blocking versus non-blocking. Synchronous code blocks everything, and asynchronous code is non-blocking. Okay, so those are like the two big keywords there. So when dealing with async code, we can use something called a promise. And before, does anyone know what we used to use? And we still use, but what we used to use solely for asynchronous code. It was callbacks, okay? And callbacks were used. So we would write something like, we'd go function, hey, let's go async function, and we would give it some parameters, and then we'd pass it a callback, okay? And it would do, let's go, do async stuff with the params, and then it would go call the callback once it was done with the async stuff. All right, so then it would call that callback. This is a really common pattern. You're going to see this used still. We still use this. We try to use promises, but sometimes this is just a simpler way of doing things. Does anyone know what the downside to this pattern is? Ugly nesting. Yep. Someone had said it earlier. They get repetitive. Totally. There's like a very famous developer term for it, and it's callback hell. All right. So let's go look at callback hell. I am like kind of sad you don't get to experience it, but I'm also like happy you don't. You would write functions that would be nested inside of each other, and they would look like this. Okay. So you would have these like very defined like sharp V's in your code. And each one of these, it would be like, all right, this is an asynchronous function. Once that's loaded, then do this one. Once that's done, then do this one. Once that's done, and it would go all the way down. All right. Yeah, flock of geese. This was called callback hell. Welcome to callback hell. And then it would have to come all the way back up, right? And so we, well, I didn't, but the concept of promises came along. So let's talk about asynchronous code real quick. So what if I said const, well, I'm not going to say const, actually. Let's just say number equals 0. And then I do something like set timeout. I'm going to use set timeout a lot here just as a way of mimicking an asynchronous call, like an API call or something. So set timeout takes two arguments. It takes a callback function, which is not the same callback we're thinking of, and it takes a time that in milliseconds that it will delay it until it runs. Okay, so it'll run this function after 1 second right here. And let's just in this function say number equals 1. All right. So if I console log, let's do this. Let's wrap all this in a function. And then we're going to return. Okay. So if I run this function, oh, I've got to give it a name, right? I thought I gave it a name of async function. Async func. All right, that's what we're going to call it. Okay, so I'm going to run async func, and what is going to appear on the screen for us? I'll open a code sandbox later. This is just to talk about promises. we're going to get, we got a 0, we got a 1,000, we got a 1, we got a 0, we got a 1, we got a 0, we got a 1, we got a 0. Straight up binary code here, ones and zeros. Okay, so let's run it. We're going to get 0 gets run, put out, output. All right. Why did 0 get output? Does anyone have any idea? Non-blocking. Timeout is async. Yep. So let's break it down. Let's see what JavaScript is doing here. We are running this function. First, it is creating a variable called number and setting it to 0. And then it's saying set timeout. And then it's saying return number. So what's happening is set timeout is this asynchronous call. It is a non-blocking call. Notice how it's still going to run. Here, I can come in here and do this. And you'll see after a second, it gets called, but it's non-blocking. It did not block our function from continuing, right? So we get that declaration of that variable. We call that set timeout. That's going to wait a second and then do something, and then we get a return number on it. Okay, so this is non-blocking. So if maybe that was a button click, right? Maybe I clicked a button and it had to do something. If I clicked a button and this was blocking, that means my whole page freezes up until this is finished. But since it is non-blocking, I can go about doing my thing, and then it'll come back later when it's ready and done. All right. So how do we get this number to be 1 when it's really 1 after the whole thing? We could do something like give it a callback. And then in here, we could say call back and call the number. So if I did this and I said console.log, we'll get it. Okay. So that works. So we can put a callback in here, but we don't want to. We can return a promise. All right. So what I'm going to write right now, what we're going to do here, I'm going to show you how a promise is actually built. I do not want you to focus on how to write your own promise, okay? There will come a time and place for you to do that. I just want you to focus on how a promise works. All right, so I'm going to write a promise, but I want you to focus on how it actually works. So what I'm going to do is this function is actually going to return a new promise. All right, remember, I don't want you to focus on how to write this thing yet. We will be doing that. Okay, there we go. Later. We just want to talk about how it works right now. All right. So a promise is going to take a callback itself. Here we go. Okay. And we're not going to return that. But it's going to have 2 items in here. Does anyone know what those 2 items are? You can all see my Replit screen, right? I just want to make sure that I'm not sharing a wrong screen with you. Okay, cool. Yeah, they are resolve and reject in that order. Like I said, don't worry about writing your own promise yet. We just want to know what resolve and reject is. Okay, so when we return a new promise, what we're saying is this promise is a contract. I believe Rain said it was a contract. And it's a contract that's saying, I'm going to come back at some point and give you what you asked for. I don't know how long that's going to be. I don't know what it's going to be, but it's going to come back at some point. hopefully. And it's either going to lie in one of three states. A promise can lie in one of three states. What are those three states? I'll let other people answer. They are, okay. I see there's a lot of this arrows going on. It's pending, which when we first return our promise, it is then pending. And then it can move in one of two directions, either into resolved or into rejected. Okay. So we're pending right now. So if I go async func, which of these three states is this in? Which of the three states is this call in? Yeah, it's a pending call. All right. We're like, okay, we sent that promise out. We don't know when we're going to get it back. All right. So what we're going to do is we're going to wait a little while and then we're going to resolve it. Okay. What do you think is going to appear on the screen when I press run right now? I'd like to get some ideas of what you think it's going to happen. Got a bunch of ones. I got an object. I got a nothing. Something's going to appear on the screen. All right. I'm gonna press run. It's going to be that pending promise for us. Okay. Well, why is it a pending promise when I've resolved it right here? Okay, this is just returning the promise. It returned that promise, and that's what we see on the screen here. Nope, no code. How do I get that resolution? How do I get that code when it's finally done? How do I access it? Yeah, so every promise can take two methods, all right, and needs to take two methods. We have dot then and dot catch. Which of the three states is dot then adhere to? Resolve, right? Our resolved promise. And which of the three states does dot catch adhere to? Yep, reject it. Okay. So does anyone know what arguments dot then and dot catch take? Almost. Yeah, they both take callbacks. Okay. So let's walk through it and let's talk about it. I'm going to do dot then right now because we don't have any reject yet going on. And you're going to see promises written like this. Remember, don't put a semicolon because then that dot catch can't be chained. Don't put a semicolon here because then that dot then can't be chained. If you're going to put a semicolon, you put it after dot catch. Okay, so these take a callback function. This is essentially what we were doing before, right? With our callbacks. But promises are handling it all for us so we don't go into callback hell. All right. Which one argument does dot then take? It doesn't have to be one. It could be multiple. But what argument does dot then take? It's going to take a response when we're doing an HTTP call. But it's not always a response. It's whatever we give this. Okay. When we call resolve, what resolve is doing is calling this function. and it's passing whatever we give it into there. So in this case, it's going to be a number. I'm going to call it num. And then I'm going to console log in here. Num. So let's walk through this. This function is going to return a promise. That's what it's doing. It's returning a promise. That promise is going to either resolve or reject. We're going to have a number. It's going to take a while for that number to get resolved to us. Eventually, it'll happen. And when resolve is called, and remember, you don't have to learn how to write this. Just know that resolve is called, and it calls this callback function in then. It passes whatever it's going to pass into that function. All right? So now when I run, what's going to appear on the screen? Instantly, yeah, it's going to take a second. Boom, there it is. Let's do 3 seconds. There it goes. All right. One, two, three. And look at that. All right. So this could, how long, what's the limit we could wait on this? I mean, I'm sure there's some arbitrary limit that your browser is going to time out on. I don't know the exact limit, right? Off the top of my head. You could look it up. But for our all purposes here is that there is no limit, right? This could be instantly, okay? It could be the fastest async function ever, but it's still an async function, right? Or it could be the slowest async function ever. The promise says we don't know how long this is going to take. And because it's going to take a long time, we're going to wait for it to work, all right? You can keep on doing your other stuff. So let's go like this. Talk about the non-blocking stuff. Let's say before promise, and let's go after promise. And I'm going to run it, and you're going to see before promise and after promise appear before the promise is resolved, right? Because it's non-blocking. All right. So it runs this. It runs that async function, and then it continues on running code. And then when it finishes, it comes back and finishes it for us. Any questions on that right now? Only really focus on that, okay? Fetch is an asynchronous function. Yep, and we'll get into that in just a minute. How many promises can be running at the same time? Whatever the maximum call stack is. I don't know offhand what that number is, but a lot. A lot. To the point where if you are exceeding that, you probably have an infinite loop somewhere that you're creating new promises. All right, I'm going to create another promise for us. And we're going to see this in action. So did you guys all do timer? One of my more proud moments. Joseph, we're going to get right into that right now, the catch thing. All right. So this timer is going to take a set of milliseconds, okay? This is going to count down these milliseconds, whatever we give it, all right? Since it's going to count down, an actual time. It is we don't want it to be blocking. We want this to be async. So we are going to return a new promise. All right, that promise is resolve, reject. All right, so we're going to have a set timeout in here, just like before. Like I said, we're going to do a lot of set timeouts because they mimic these async calls really well. And I'm just going to pass milliseconds into it. All right. So whatever milliseconds we do, that's what it's going to say. So let's check this out. Console.log. Finished. All right. So how do I call this function now? You guys walk me through it. I'm going to call timer, and then I can pass these milliseconds in. So in this case, I'm going to pass 1,000 milliseconds in. All right. I'm not going to pass 80,000 milliseconds in. Maybe I'll do a 30,000 millisecond for our break. So I'm going to pass just 1,000 milliseconds in. What's 1,000 milliseconds? In layman's terms, 1 second, right? So what's going to appear on the screen when I press run right now? We've got 2 finished. We've got a promise. We've got nothing. Remember, eventually it does. We're not, okay. Remember, when I pass that, what this is this is our pending promise. Okay. This is our pending promise, right? So when I run it, and it'll eventually console log, so I don't want to console log it right now. Let's do that. It's a pending promise. So we just get the promise back. All right. What do I have to add in order to get the actual data that I want back? We have to do then, right? Go then, and then takes a callback. Remember, and let's go. I'm going to do a little outside the box here. Let time equal 0. I'm going to say resolve time. So that's just going to be our milliseconds passed back to us, right? So what is going to be resolved? What are we going to get back here? In .then, we're going to get something. Yeah, we don't know what it's going to be yet. What if I change this to 10,000, right? We don't know what it's going to be. It's just going to be whatever our promise resolves. And I'll just say, if you're not writing your own promises, you are going to have documentation that tells you what it resolves to, okay? So when we go to use Axios today, you're going to see that Axios has information that tells you exactly what it resolves to. All right, so it's just going to resolve to, I'm going to call it time. All right? And now we can console log. It has taken time. Ooh, does milliseconds have 1L? Ooh, I'm not the best speller of milliseconds. Does milliseconds have 1L or 2? Thank you. All right. So, and now look. Now we're getting that back, okay, after a second. So if I change this to 3, Now, 3 milliseconds later, this could be whatever. This could be 100 milliseconds, right? It's going to still, you're going to see a little flash in there though, right? Even though it's 100 milliseconds, it is a tenth of a second, and we still get that flash because it is an asynchronous function. Christopher, you should always know what your promise is. You are not going to be writing your own promise, by the way. I just want to make sure that's clear. You're not going to be writing your own promise right now. So if you have an asynchronous function that returns a promise, then you're going to be able to, there'll be documentation for it. All right, so let's come in here and let's say that we want to make sure our time is always more than 1 second. All right, let's just say for the heck of it. So what can we do to say that our time is always more than 1 second? Nah, let's do this let's think very naively right here. Yeah, let's do an if statement. We'll be like, if, let's do this. If milliseconds is less than 1,000, we want to do something. Else, let's do this. Right? So if it's less than 1 second, we want to do something. Otherwise, let's set our set timeout and let's resolve it. So what could we use to say, hey, you've made a mistake. This is wrong. Go back and figure it out. We're going to use .catch eventually, but what the promise is going to do is it's going to reject this. And it's going to give us an error message usually saying time needs to be more than 1 second. All right, so it's going to reject it. So let's do 100 and let's run our .then. And this is never going to resolve. All right, so we always need a .catch in order to get our rejections. You always need a .catch. If you're going to write a .then, write a .catch. Okay, that's just how it goes, right? And so .catch is also going to take a callback as its only argument. And instead of whatever it resolves to, it's going to be whatever it rejects. So we're going to usually get an error message off of this. All right. And now we can just say full.log in catch made an error. And I'll put our error message in there. All right. So now we instantly get that. But it could take a while sometimes. Sometimes it takes going all the way to a server in China, and then that information has to come all the way back to us and said, oh, there was an error. Right? This was instantaneous, almost. It was a promise, so it was still asynchronous. But we get it. In catch made an error. Time needs to be more than 1 second. Okay. Let's change that to 101. Oh, nope, that's 10 times as many as I wanted. And now we get it back perfectly. All right. So are there any questions on this right now? Because we're returning the promise here. Because that's a replit thing. Don't worry about that. That's what's being returned to the screen. You will not see this normally. If you ran this in the console, where is it at? How do I do it? I forgot. Oh no. Let's just do it this way. If I ran this in the console, yeah, we still get that promise back. All right. It's just because that's All right. What was being returned to the screen here? Time isn't doing anything. We're just using that to. Any questions on dot then and dot catch? Because this is the important part of the lesson here is dot then and dot catch. I showed you a little behind the scenes so that you understand what's going on. But this is the important part here. Dot then is going to be our resolved promise. Dot catch is going to be our rejected promise. Why might we chain multiple thens? I'm going to copy paste this and we'll chain it. This parser is going to take a new time. All right. It's going to return another promise, set a new timeout, and then if it's more than 1 second, we're going to get our parsed time, whatever that seconds are of it, okay? So it's very similar to this. It's just it's going to resolve this time with a, it's going to divide it by 1,000. Nothing fancy going on here. Same exact thing. Set timeout, takes milliseconds, and then it will just do it 1,000 milliseconds for this one. Okay. Any questions on that? It doesn't really matter what's going on here. Just know that it's returning a new promise to us. All right. This one's going to be a little funky. So I'm just going to say parser. I don't have to call this. Why don't I have to call this? Anyone know? And not only do I not have to, I can't. Yeah, because resolve is calling it, right? So imagine this looks weird to us at first, but it's not weird, okay? All it's doing is this. I mean, that makes sense to us. Like, oh, cool, there's a function. That's our callback function. When timer resolves, it's going to pass the time into that function, and then it's going to call it, right? We already know that's going to happen. That's what resolve does, okay? So when I just say parser, that's all the same exact thing. That's all it's doing. We don't have to call it. We don't have to pass anything in because we have that happening already up here. Is there any questions on that right now? I want to make sure that that's clear. You're going to see a lot of stuff. Like, remember when I just wrote console log and I didn't put any parentheses? Same thing. And in fact, I can do that again. So look at this. We've got a promise that is being resolved, and then we're calling a new promise in here, right? So how would I get the information? So I could like do something like this, right? And I could get new time. Oop. And then I can call new time in here, and then I can say dot then, right? And then we get this other thing. What is this starting to look like? Yeah, it's starting to look like callback hell. And that's what we don't want, okay? Because what if we have 10 different promises that we have to push this through? The beautiful thing about promises are that if we return a promise, like we are when I say parser, we can just add another dot then. All right. So it's going to say timer resolves, then call parser. When that resolves, then do something else. All right, I'm going to do this. And I'll say dot then, and we'll just say console log. Same thing with parser. We're just going to console log whatever we get resolved to. All right. We don't have to call it because it's already calling console log for us and passing that in. All right. What do you think is going to appear on the screen now? I don't see any console logs in here in any of these. We're only console log is happening right here. And this is a little advanced. I'm not going to lie. You're not going to have to get this far tonight, but I want to show you why we use promises, because otherwise a callback works just fine right here. Greg, it's the same thing as this. Console log is a function. Parser is a function. It just passes the information into console log. We're going to get 1.001 seconds have passed. There we go. All right, so it goes through here. It waits 1,001 milliseconds, and then it resolves 1,001. Then we pass 1,001, what resolve does, into this function. It brings a new promise. It only waits a second, no matter what it was. And then if it's over 1,000, then resolve gets called again, and we're just console logged it. Okay? Yeah, it's fine. The math is whatever, right? It's the fact that it went through both of these, and we got that 1.001 seconds have passed. All right? We should get 2 seconds have passed now. All right? Cool. Now, before we take a break, what is going to be console logged here? We're just going to console log the error, and we're going to say timer, and we're going to say parser. Write your, are we going to get timer or are we going to get parser with 200? Write your guess in Slack. Let's take a 5-minute break, and we will find out after these messages. See you in 5. All right, the time has come. We got timer, right? What if we made this less than 10 milliseconds? We're like, we don't care. We want it to be less than 10 milliseconds now. Which one will we get? Timer, parsed. Will we get time must be more than 1 second parser? Will we get the parsed time? Which one will we get? And see, it took a little while to get that parser one in because our timer was fine. It resolved. It took a little, well, it took 200 milliseconds to resolve. But then we also took 1,000 milliseconds to resolve that parser. And yeah, so the same catch is used for all of the promises in the row. Okay, so the same catch is. But the thing you must remember, and like I said, this is a little outside of the scope of what you need for today, but I just want to talk about promises. Thing you remember is that once one promise is rejected, they all get rejected in the chain. Okay, so it'll run, say you have 5, you have promise. And it gets rejected right here. This will run. That will run, but this will not run. And that will not run. Okay. So as soon as one of them is rejected, the chain breaks and the catch gets thrown and everything is done. Okay. Like a regular old if else statement. Sure. Except the fact that every statement gets run unless it's rejected. Right. So sort of like an if statement. But where in an if statement, only one of them gets run. So just keep that in mind. For tonight, we only have to worry about one promise. All right. One promise is all we need. Okay. So let's see if there's any questions right now about promises, other than how to write your own. And we will jump in. You could potentially in the catch just have it start again. Sure. Yeah, you could. One promise to rule them all tonight for sure. Any other questions right now? Aaron, I would say you could potentially in the catch have it start again, but you could see how that possibly could lead to an infinite loop, where it just never stops running because there's always going to be an error. So you got to really pay attention if you're going to do something like that. But you could do that. I'll leave it open for one more second for questions. All right. Let me. This should work for you. I don't use Replit all that often anymore, but you should be able to click on that and get to this code. Remember that there's this down here. So, yep, this should totally work for you. All right. So let's jump into some React code. Back to trinkets. Beautiful, wonderful trinkets. Well, let me open this all up. Okay, one thing about this is that I am going to be running a server on my local computer. So if you want to follow along, you must also run this server. I will give you a link to it. You will need to clone it, install it, and start it yourself. Okay, I'll show you how to start it right now. So Rain, async await is fancy syntactic sugar put on promises. So async await is just promises without using dot then and catch. Instead, we use a try catch block. All right. So once you understand promises, async await is very simple to pick up. All right. You just got to understand promises in order to get it. It's really simple to pick up once you get promises. And are really cool and work really well. Async await works really well for multiple promises. But we are not going to be talking about that officially in Lambda right now. Okay, so I have cloned this trinkets API. I'm going to yarn this thing. No log file found. What? Sure there is. Oh, what? There's the log file. Let's go CD trinkets. Must not have CD'd into it. And now we'll yarn it. There we go. Yep, even the pros forget to CD into their project folders. All right, now we'll yarn start. Cool, server is listening. That is all I am gonna do. You do not need to go in and mess with the server or do anything to the server. Just know that it is listening and we can hide that away. All right, we're just gonna hide it. Don't close it if you're following along. The cool thing about Code Sandbox is it will allow us to do localhost and hit that server, but it will not allow you to hit my server. So you got to install and do your server yourself. Sandbox link. Make sure that this is the right one. Let's save this thing. There we go. Sandbox link. Cool. It's Dustin's trinkets. We got to change that to Dan. Where is... Dan's trinkets. Okay. So... So now, instead of getting this information from our data file in here, we don't have a data file any longer. We want to. Ooh, I like Dan's Delights. All right, I gotta pause for that one. Dan's Delights and Delectables and Dealies. I like it, but I gotta give it to Dan's Delights. All right. Okay. So we are no longer going to be getting data from a data file. This is a real working website now, right? A real working web application where we want to get dynamic data, okay? We want to get data that's up to date and maybe one of Dan's Delights is sold out, or maybe we got some new stock in of something else. We want to make sure that everything we do is fresh, okay? And so how do we make sure that it's fresh? We can't just put a data file in our project, deploy it, and assume that that's going to be the latest up-to-date stuff. How do we get things that are fresh data for us? And just in a very, very, very high level. Fetch. Fetch some JSON, get from an API. We're going to we're going to go hit a server, right? We're going to hit a server that keeps all this stuff up to date. And we're going to get this data back from the server, all right? And so what we're going to do is we are going to use a library called Axios. So if you have looked at Axios, not the news site, but they put out a version of Fetch for us. So you've gone through the HTTP Ajax stuff. We are moving into the day and age of the fetch method being available to us on the newest browsers. Unfortunately, fetch is not available on every single browser. And so if we want to make sure that we're polyfilled, we want to make sure that we work with older browsers, we're going to use a library still. So you are more than welcome to use fetch, but we're going to use Axios because Axios will work across browsers. All right. So Axios is simply wrapping an XML HTTP request. If you have ever tried to write your own XML HTTP request, you know what a pain in the butt it is. Okay, you've got to set all these event listeners on an open. You got to wait for some data to come in. You've got to do a bunch of different handling of the actual data, and then it gives it. Then you can finally get your data back. Okay. Thankfully, Axios takes care of all of that for us. All right. So Axios make XML HTTP requests from the browser. We can also make HTTP requests from Node, which we'll talk about when we get there. Supports the Promise API. This is why we talked about promises so much, because Axios returns a promise to us. Intercepts requests and responses. Transforms the request and response data. This is all stuff that we would have to do manually ourselves. All right. Automatically transforms for JSON. That's a one step that we don't have to worry about. That's an extra promise on there. And so we get a bunch of stuff from Axios for us. Okay. Axios is so easy to use. It is the simplest way to send HTTP requests. It's so easy. If you were around when jQuery was at its height, many companies still use jQuery simply for the Ajax method. And it's pretty easy to use as well, but this is even easier than that. So just understand that that's why we use Axios rather than the native fetch. Is just based on the ability to use it cross-browser, and because it's super easy, and we don't have to worry about what's the syntax. We can only worry about what's actually happening. Okay. All right. So first thing we need to do is we need to add Axios as a dependency. We see that it's already in here, but if we're going to add it, we're going to yarn add Axios. All you need to type in is Axios. It's the one. Okay. Axios. So there's a retry Axios for, I forgot who it was that asked about using a catch to send it again. You can do something like that. It's out there. All we need to do is grab Axios. Okay. So then once we have Axios, what we are going to do is we are going to import it, right? So we're going to, that's a good spot, import, and you just Axios from Axios. All right, pretty simple. We bring it in now. All right, now it's time to start thinking about what we're going to do. So we want our page to load, right? We want there to be no blockage in the loading of our page. And so we want to get these items once our page is loaded. So what's the proper place to put this server call? We've got a lot of component did mount. What if we put it in render? Why not? It depends, but we're going to set state. Okay, right? We're replacing this set state here with an API call. Yep. I don't think it's too much data, but since we're setting state, you can never set state in render. Remember, because that'll set up an infinite loop. So we're going to put it in component did mount. It just seems like the logical place to do it. It's going to not block our page from loading. It's going to allow our page to load up while it goes and gets the data, and then it's going to bring the data into our site. Okay, so what are we going to use now to send this server call? We're going to use Axios. And let's go look at our documentation. We can do a couple of different things. We can do a .get, which is our GET request. We can also call it, where is it at? We can just call Axios plainly and put an object in as its one argument and do a method of get. This is very familiar to those that have used jQuery's Ajax method. This is how you set it up, and then you'll do a success and you do a reject on that instead of using a promise. But this is pretty familiar to that. The easiest way to do this is our .get. Okay, so this is our .get verb. Right, this means we are going to send a GET request to the server. Who can tell me a very, very, very simple way that anyone without using Axios or without writing a web application or a web page can use a GET request? Yeah, a GET request is right here in our browser. What our browser does is it sends a GET request to ESPN.com. ESPN.com responds with this GET request with the data that we want. It's actually an HTML page, and it'll eventually be some JavaScript, some CSS, etc. Okay, this is a GET request. You have been creating GET requests I want to say entire life, maybe not your entire life. Maybe some of you your entire life, some of you half your life, some of you a third of your life. But but we've all been sending GET requests for a long time without even knowing it, right? Because that's all this is. Under the hood, when I go to ESPN.com, oh, this is a bad one to show. Well, let's go to Google. Even though Google's a bad one too, but still a little bit better. Right, there's our initial GET request right there. And actually it was a 301 because it was actually www.google.com. So there was our GET request, right? And it sent us back a bunch of stuff, right? It really sent us back an HTML page that went and got more stuff. But yeah, that's the GET request. We've been doing that a long time. So we're going to just say .get. .get is a method. All right. What is the one the one argument that .get takes? Takes a URL of where we want to get it from. So if I say .get and I say this is going to give us the same stuff that typing google.com into our browser does. All right. A little bit different. It's actually going to give us an HTML page. And we can see that. Let's do this. Can use the curl command, and we'll just go HTTP. And there it is. All right. This is a .get. This is just our HTML that we got from Google, and that's it. That's our .get. Okay. So if I were to type google.com, we would get this HTML page back. All right. But we're going to type in, yeah, definitely hacking Google right there. If that's hacking Google, then every single one of us hacks Google every day. All right. So Google would loves to be hacked in that way. So what we need to do is we need to get something from our server. You'll learn how to build your own server in 5 weeks. You're going to enter node. But for now, we're just going to type in localhost. What is localhost? Does anyone know? Yeah, it's my computer, right? Just like when we type in localhost and then our port to get our React app, we can also run servers on our localhost at the same time. Yeah, it's pretty sweet. Code Sandbox is awesome, Christopher. So Code Sandbox will actually hit my localhost as long as I have a server running on it. It's pretty awesome. Yeah. So when I first found out about this, it blew me away. Localhost is also 127.0.0.1. There's a lot of different IP addresses for localhost, or you can just type in localhost. Okay. So we are going to go localhost, and remember our server was running on port 3333, and we're going to hit what we call an endpoint, and that's items. Okay. And that's it. So it's going to then send a request to the server at this address and say, hey, whatever you do, forget, give it to me. And the server is going to say, that seems like the right address. You seem like a friendly person or a friendly machine. All right, here's the data you requested. Okay. So when I write this, what does this return to me? We've got a promise, an object, a promise, an object. More guesses, please. JSON, HTML, array of all the items, my server, a response. Love it. Eventually, all of these are correct, right? For now, Axios.get, when I call this, just like when I call timer, is going to return a promise to us, okay? Because how long is it going to take to go to this server and get these items? Does anyone know? I don't. Nobody. No, who knows? I don't know. Where's the server at? Is this server behind some sort of reverse proxy? Is it a CDN? Is it, in Antarctica? Is it in Africa? Is it in Chicago? Who knows? I have no idea where this server is, and it could take a long time to get back. It could be very fast. Ours is going to be very fast because it's on my computer. But it could take a long time. It could take 1 millisecond, or it could take 3 minutes. Who knows? But this is a promise that says, as long as that server responds to me, I'm going to give you some stuff back. Whether it be a fulfillment of that promise, or the resolution of that promise, or a rejection of that promise. We could do console time on here. I don't want to get into that. So yeah, it could take a while. It could be fast. We don't know, right? But that's why we're going to get a promise back, because this is like the classic asynchronous call here, right? So yeah, it depends on what operating system those servers are running too, and how much load they have, and how much load their database has, right? We don't know where these items are coming from. These items could be stored on a database that's away from the server. So the server has to make a call halfway across the world to the database to get that data to send the data back to you, right? So the thing is we don't know. Since we don't know, it's a promise. And how do we get the data back from that promise? Yep. We're going to do a dot then. I want you to always get in the habit of writing, when you write dot then, to write dot catch. Catch. Okay. Not cath. When you write dot then, always write a dot catch. All right. Even if your dot catch just console logs the error, it's going to save you some heartache and a headache. All right. So we're going to say dot then. We'll come to our catch later. And what is our dot then take as its argument? Callback. Let's go look. Since we did not write this promise, look, I don't see new promise anywhere on this page. Let's go look at our documentation, and you'll see that we have a function signature right here that tells us exactly what it's going to give us back. It's going to give us back our server response. Okay. So anytime you have a third-party library or a promise that you're going to use that you didn't write, you're going to have a function signature for that dot then. This could a promise resolve with multiple arguments for your callback. Can it? Got two no's or an unsure. We got an actual no, three unsures, an actual no. Yeah, it can. Sure, it can. Why not? It's a function, right? That's all it is. So I could have come in here and done resolve milliseconds plus my name and I don't know, true, right? And my then would have could take those three things, right? You're not really going to see that very often. You're going to get usually a response or the data that the promise manipulated for you, but it can. And you could write your own that does. For us, we're going to get a response. Okay, this is our response that the server gave us. This is also a response the server gave us that Axios has graciously gone and done a lot of things for us. It has turned the data from our response into JSON for us. Well, it actually has parsed the JSON for us. So now we don't have JSON, we'll have an actual response data object. It has neatly given us our headers, our status code, a status message. It's done a lot of really cool things for us. It's really nice to have Axios do this stuff for us because we don't have to worry about doing it. So let's just do this. Let's just console log our response. I highly suggest whenever working with a new API, unless you have access to the documentation for that API, which you should if you're using it, you should just console log your response object and see what you get. So let's look at there we go. Let's look at our response object. We got an object. This is all of response. We have data. We have a status. Does anyone know what this status code means? 200. Yes, all of the above. It officially means okay. But it means successful, completed, everything's good. Yeah, you're fine. Here's your stuff you asked for. Everything looked good. There you go. It is very generic, a 200 is. Did you get a link to the Wikipedia status codes? Wikipedia. HTTP cat works too. These are the kind of the official status codes. So these status codes have meaning, right? They mean something. And so a 200 just means okay, right? That means a standard response for successful HTTP requests. The actual response will depend on the request method, right? This is generic, standard, right? So let's look at 201, means created. So we're going to look at post and put and delete on Wednesday, but it just means that we have asked the server to create something on the database or something for us, and this is telling us successful, and yes, it's been created. Look at 300s. 300s are mostly they're all redirects. So 301 is moved permanently. So remember when I did that, show you that Google network request that we had a 301 because google.com doesn't exist, but www.google.com does. Move temporarily. So say you have a placeholder or something in place, you might have 302 go there. 400 are client errors. And client errors are errors that we have asked the server to do something that it doesn't understand, that we have malformed data that we sent it, that we are unauthorized, that payment is required, we can see here. Forbidden, just anyone that's forbidden from it. 404 is the classic. Everyone knows a 404. It's not found. So that's any data. That's not just a web page. That's any API. If you ask it for something, it's like, I don't know what you're talking about. I cannot find what you have asked for. So these are they all have meaning to them. There are these 3-digit codes, and then 500 is 418 is I'm a teapot, which is pretty great. Hey, it's an April Fool's joke. Awesome. Traditional April Fool's jokes. Not expected to be implemented by actual HTTP servers. It's just I'm a teapot. All right. Then 500 are server errors. Okay. Pro tip: respond to every HTTP request 402, get rich. I think that's how it works. I think that's how economy works, right? Once you get a 402, you just pay up. But so you get these server errors, and then of course our 100s, which I didn't go over, are pretty basic. I don't think I've ever used a 100, but they're there if you need them. Cool. So these have meaning, right? So we see that we get a status of 200 from our server, and the cool thing is Axios actually tells us what it means. Okay, all right. So that's a little fun thing Axios does. Gives us our headers. So if we have any different offset header stuff, we get that there. We got a config, which we're not really going to worry about that right now, and we get our actual request. So this was an XML HTTP request, which we sent out. All right. But what we're really focused on here is this guy right there. All right. So data. So data is going to be an object or an array or whatever it is, right? The data that the server wants to give us. So if I say, hey, go to this address and get me something, this is what we're asking for, the get me something part, right? So I always say come and look at your response object because this could be called something else. Sometimes it's called message. So if you use the dogs API, it's called message. And it also depends on what language your server is using. The server is using Express and Node, and I believe Express always puts it in data. So it depends. Yep. So in this case, what we're going to do is we got a response and we got data. So we want to set this data to our state for our items, right? How do I do that? Yeah, we're going to use set state in our .then, right? So we're going to wait for this to resolve, and then we're going to set state. All right. So nothing changed on here. Um, let's see if we got this stuff pass it down. Yep. We should now be able to click on shop now and see our items. And there they are. All right. So let's come back up here. Wait a second. We go shop now. No items because our items are nothing. But if we send this request and then we set state based on the data we get back, there we go. We now have our items. Let me just show you. You'll see the flash, you'll see the page load, and then shortly thereafter, you'll see the items load. Of course, this is very fast because the server is on my own computer here, but so you see that little flash. The page loading and then the items loading. So are there any questions on sending a GET request? So I'm just setting the state. I'm just setting the data on the state. Items itself is doing its own thing, right? It's going through and mapping and doing its own thing. And there's nothing different other than we're not getting the data from a file than what you've been doing all last week with this. Okay, so if we go into items, item list, we'll see that it gets those props dot items and then it maps over them and creates these things from it, right? So we're not worried about what's going on in here or how this is being presented. We're only worried about how we get that data to pass down to it. Does that make sense? Cool. Any questions right now on Axios.get.then promises? We're going to talk about catch in a minute. Excuse me. All right, let's take another 5-minute break. We'll come back. We'll talk about a couple other things. We'll finish this up and we'll get you writing your very own server API calls. Cool. So see you in 5. All right, come on back. Let's finish this thing up and get you building your own HTTP GET requests. So, kind of wanted to point something out. I mentioned that console, what we get from Axios, is a little bit different than what we get. The Axios does some stuff for us. So I'm going to console log that response again. And then I'm going to open this up in another window. Open our network. We'll refresh this thing. Okay. Oh. So it's going to be called items. There we go. Items right here. Let's click on that. Let's click on preview. So this is actually what we're getting back from the server here. And this is what we're getting. Okay. That previewed for it's in parse JSON form. Response. There we go. So this is what we're getting. We're getting what's called stringified JSON. All right. Well, just JSON. The Axios actually gives, and this is our whole response. All right. It's an object with, or an array with a bunch of objects in it. And it's JSON. And this is it. This is our response. A little bit different than this, right? Like, look how nice and neat and tidy this is. I don't see any cool status message in here anywhere. Let's status message. Is it message? No, doesn't exist. Right? So Axios is doing a lot of really cool things for us. It's bundling it up, making it very easy to consume this data. Very easy to come in here and say, like, the data is what I want. That's it. That's what I need. And then it also parses that data into JavaScript from JSON for us. So it's pretty cool stuff that Axios is doing for us. And that's one of the reasons we use Axios. If you were to use the native fetch method, you would have to run JSON parse on this yourself. You'd have to go in to your response headers and find the status code and do things based on that. You'd do it all yourself. Just makes it a little bit easier for us. Cool. All right. So does anyone have any questions on this set state? We set the state with our response data. And really, like I was saying, before we were doing something like this. Right? And then just coming in here and doing data. Right? We were just getting it from our little data JavaScript file in here. Ooh. So I want to say that it's what the server calls it, because the dogs API calls it a message. So it's a little weird. So that's what the server calls it. Axios just goes in and manipulates it, makes it usable to us. Cool. Although I think that it might always be in data on Axios, and then inside of that data might be an object that has a message key that it has the actual stuff. You'll have to look into it further, but just console log your response every time you get one, and it'll tell you exactly what you're getting, and you can look through it and see how everything is formed. Okay. So now, instead of bringing that data in, we're going and getting that data from the server in an asynchronous call. And we are then, once we get it, then we're setting the state on it. Yeah, I've seen data, lots of stuff like that. User, data, user, things like that. Depends on the developer that built the API, the language the API is written in. Axios depends on a lot of things. Cool. And then once we set the state, it's setting it from nothing to something, and it's coming back here and here. And let's actually do something. I'm gonna got a little extra time right now, so I'm just going to mimic a really long server call. There we go. So now let's say our page loads and we're still waiting on that. We're still waiting on that data. It's taking a while. And there we go. Now it's back. Okay. Could we destructure the object? Well, and then, yeah, sure. You could do that. If you really were, you could go data. But this is making things a little more complicated than it needs to be. But yeah, that works. Boom. Cool. Sorry, Rain, what did you mean by back button? Robert, where would prop types come into play when doing an API call? Prop types are going to come into play, right? So let's think about it. What would we set the prop types on for app? Is app taking any props? Oh, okay, right. Oh, well, you would have like a really nice, beautiful loading icon there that mesmerizes you for a few seconds. But is app taking any props right now? No, app's not taking any props, so we're not going to set any prop types on this. Items list is taking props. What are we going to set the prop types on items list? So we come in here and we'll say items list dot prop types. Well, I would set items, right? Because it takes the items prop. And I would set that to prop types dot array. And that's all. You can go in there and get deeper with these prop types, but you don't have to either, right? If you know exactly the structure of the data you should be getting back, you can come up here in here and say shape, right? And then put what you want in here, right? But in this case, we can just put array if we want. So that's how I would deal with that. Unless you were very certain exactly what, and if also if your application depended on it, exactly what prop types we needed, right? Does that make sense? But we're passing that array down, and it's an array no matter what. This is an array. That's an array. They're both arrays, just they have objects in them. One has an object in them and one doesn't. Any questions on any of this stuff? Any more of this stuff right now? We got one little thing to go over, and then we're done for tonight. It shouldn't, Robert. No matter, depending on what we pass down. That's it. Yep. Cool. So, what's the one thing I am missing from this right now? Anyone know? What are we getting in that console there? Yeah, catch isn't doing anything yet, right? Error, and I'm just going to console log the error. I don't really have much to do here. Where could you see this coming really into play in an application? Think about like a use case for your catch here. But like I'll say like in a React application right now we're just going to console log the error, right? This isn't doing anything. This doesn't help anyone out. It helps a developer out if they can recreate the problem. Yeah, so let's think of like something like a wrong password, right? Say you entered a wrong password and then you get 40, who I got to look at it, 403, 402, 403, forbidden back. You're like, oh, well, obviously that's the wrong password, or a 401, unauthorized. Um, failed or has not yet been provided. So it's going to definitely be a 401. So we're going to get a 401. So that point, what we could do in our catch is maybe set state to have error message appear on the screen, right? Error message is incorrect password, right? So you can use this catch to do things. Right now, we're not using it to do anything, but I would say like, yeah, incorrect password, incorrect authentication, authorization. If you try to upload something and you provided the wrong file type, that could be something you would use there. There's a lot of different use cases for it. Like I said, it's not just console log error, although that's what we're going to see right now. So let's do this. Oh, we did not get an error on that. Where's our console log at? It should get. Oh, we got 4 seconds. Wait 4 seconds, and there we go. There's our error. That's a really bad error. Let's go look at what our error looks like in here. We got error, network error, connection refused. Let's go into here again. Okay, we'll see an error better in here now. Okay, yep, we got a error connection refused. Okay, so yeah, we didn't even get an error back from our server. Our server does not exist at localhost 333. It exists at localhost 3333. So we're getting an error now. So nothing's appearing on the page. And at this point, you should set an error message that said like, error retrieving items, please check back later or something like that, right? So that your users aren't just sitting here waiting forever, which as Rain said, you're probably going to wait 5 seconds and then leave because nobody has time for that. But you should have something on here that catches that error, that displays an error message to the user, especially if you have a blank page like this. Cool. That's it. That's what we got tonight. Any questions on any of this stuff? Let's load that back up. And I'll actually get rid of this set timeout because that was unnecessary. There we go. We went and got data from our server, and now you know what I should have done? I should have had the server open in another window and added stuff to it. But that's fine. And taking things away. So this is always going to stay up to date now. As long as our server's up to date, these items are going to stay up to date every time a user comes to our page. Questions? Any questions? This is your time. We'll talk about delete on Wednesday. If you want to go a little ahead, that's your prerogative. But we'll talk about it on Wednesday. I believe you can get an actual unicorn bowl. I don't know where these came from. I'm sure it's takemymoneyplease.com, but I'm not 100%. Where's that unicorn bowl at? Is it the top? There it is. Oh, that's pretty sweet. It's kind of expensive though. $40. I think these are all out there. I didn't build the project Dustin did, but I'm certain these are all out there. $42. It better be sweet. It better be like really, really nice because that's a bowl for $42. All right. If no questions, that's what we got tonight. Let me give you the code Sandbox once again. Other than that, have a good night, everyone. I'll see you on Wednesday. Have fun with your project tonight and tomorrow. Good night, everyone.